All right. DPE, it's so great to be here. I was actually talking with some of you last night about unsound tests and how that's affecting quality at your companies. And I was thinking to myself, wow, I didn't know I would meet anyone here that would care more about unsound tests than me and my team here at Uber. We're actually here today to talk a little bit about that, but about testing across Uber and really how we built some really cool stuff over the last 4 or 5 years, and how all this actually increased quality and productivity across the whole company. So my name is Quess. I'm one of the engineering leads on the test infrastructure org within our developer platform team. But I work on everything microservices. So anything related to development of them, testing of them, monitoring of them, even how to secure them.
Yeah. My name's Daniel. I used to be the senior manager of testing at Infra. And I pretty much spent my entire career building up testing infrastructure at Uber.
All right. So today, just real quick, we're going to cover a couple of key things. Daniel's actually been at Uber for over 9 years. So he's going to give us a little bit of history on why we actually are solving this problem space and why it's important to Uber. We'll talk a little bit about the different testing strategies we encountered along the way. And then we'll actually get to, hey, what do we actually build? And most importantly, how did this actually change the engineering culture? One of the key things we're going to touch on is testing is actually not just a technology problem. It's very much a people problem as well. And then at the end, we have a little bit on forward-looking, what are we going to do in the future, right?
Nice quest. So I'm pretty excited to share a story of how testing came to be at Uber. So 2015, it's kind of hard to claim that transportation is as reliable as running water when your outages are actually going viral. And so in 2015, when I joined, we had some pretty epic incidents. And we had to ask ourselves the question, how are we going to reduce outages? And that's really where our testing story began, because we knew that we had to do something about testing. It was just not something that we couldn't afford to not do anymore. And someone once famously said at Uber that the best real world tested environment you will find is called production. And I think there's some truth to that, because it's really the only environment where you have real customers. Hopefully, unless they're also in staging. But that right there is actually called blackbox monitoring. And it was the first thing that I built at Uber. It was also the easiest way for us to get into testing, because we didn't really have much testing infrastructure. Just to give you a little background on what blackbox monitoring is, we generate synthetic tests, basically synthetic traffic with end-to-end test cases to figure out, is Uber actually operating? And we try to run that in as many cities as possible to give us a really good early signal. And so on a good day, this is what Uber looks like. On a bad day, which happens, it's fairly red. And so there was actually two things that we had at Uber at that time that allow us to do this. We had a concept called test accounts and also test tendency. And that's something that Quest is going to go over a little bit later on in his talk. But that was enough for us to get started. And so we got really good at this, actually. We provided a very stable signal, and we were able to detect many of our incidents way before anything else could, because all we had to know was, from the user's perspective, were they able to get a ride? Now, that worked for us for a very long time, but given over the years, we scaled up quite a bit. And so even as we introduced things like incremental rollout and constantly probe production as we rolled out, when we did detect an incident, at the end of the day, we were still having an incident, and customers were impacted, and all of Uber basically had to stop and figure out what was happening. And that was a big productivity loss right there. And also, one of our smallest units is really a city. We really weren't able to just roll out change incrementally to customers in a city. It was all or nothing. So even a rollout like this would be an incident for us. So we had to ask ourselves the question, how do we go from detecting incidents to preventing these altogether? So how do we turn this reliability problem into something that was a quality problem? And so this is what we had to figure out in order to shift testing left and actually prevent these things from happening. Now, this graph right here, this is a dependency graph we generated from our Jaeger traces. Yes, Uber has a lot of microservices, and the dependency graph is quite wild. So testing microservices is pretty hard. And like any reasonable organization, we wanted to start with the testing pyramid. And so, in reality, back then, we really only had mostly manual testing and unit tests. And when we start looking at the data, that testing pyramid just didn't fit Uber's architecture. Most of our complex business logic required multiple services. And when we looked at our postmortem, over half of our postmortems were caused by code and config changes. And looking at those postmortems, seeing how could we have prevented this issue right here, half of those could have just been prevented with some kind of end-to-end or integration test. So that was really telling for us because, we wanted to do this test pyramid, but it just wasn't something that was going to fit for us. And now that we look at, when we start to search for test pyramids, we see some of the other shapes. So I think other companies are also kind of realizing that we really need a lot of integration tests. This is something that's kind of required for microservice architecture. So I'm going to hand it over to Quess to talk a little bit more about what we did, and he's going to talk about some of the innovation we did.
All right. So thank you, Dan, for setting the context around the problem that we're trying to solve. So if you didn't catch the last few slides, it really is an emphasis on how we really invested in integration testing at Uber because microservice architecture that we use at Uber really demands it. But this wasn't an easy journey. So, one of the stories I have to share is, back in 2019, I remember having a conversation with one of our few distinguished engineers, and he told me, "Hey, Quess, I know you guys are working super hard on this problem, but I look around the industry and I don't think anyone has actually solved this. No one's really made it easy. So maybe this is just a hard problem that isn't solvable in general." I don't think he meant to be discouraging, but I kind of was like, challenge accepted. Let's try it. A couple of the common strategies that we looked at that other teams at Uber had experimented with. I actually came before Uber from a small startup where the directive was like, hey, I want to run all my tests on my laptop without internet locally in 5 seconds or less. Great principle, but when I came to Uber, I quickly realized hey, this strategy wasn't going to work out. So, one of the things that people tried is, hey, I want to start everything in a Docker container, stitch it together using Docker Compose. It's fully reproducible. It's hermetic. It's great. But as Uber's complexity really grew, it actually requires every service, your service's dependencies, its dependencies, and it becomes quickly like a huge transitive problem you need to solve. We couldn't even get all of the platform teams to ship reliable Docker containers for some of the custom database solutions we were using at the time. Another strategy that teams had tried and didn't work out totally was the concept of a shared staging environment where, all the teams will deploy their changes to a staging environment and then you just run your tests there. Pretty simple, but again, when you have 200 teams all developing in this environment, all it takes is one bad change to break it for everyone else. And then you got to run this expensive exercise of who's going to bisect the bad git commit, revert it, and it's a bunch of wasted time lost for everyone. And so in these two examples, one of the learnings for us is, hey, we can't rely on any solution that requires everyone to be aligned to do the right thing. You're inevitably going to run into some critical business team that has some top-down priorities, and they're not going to be able to participate in your testing initiative.
I would even say it's not even doing the right thing. It's just, it's not reasonable to expect everyone to drop everything and do a migration for testing. So,
yeah. And so fast forward to roughly 2021, after a bit of iteration, we came up with a new approach. And that approach is testing against production. So something that Dan mentioned earlier is Uber used to test in production. This is actually different than testing against production. So when you test in production, you're actually rolling out your changes to real users and using them to see if your changes are working as intended. Testing against production is a way to use the production environment in an isolated fashion because production is reliable. It has SLAs, people are on call for it, and it already exists. So you don't actually have to set anything new up. And we actually started a company-wide initiative called BITS. BITS stands for Backend Integration Testing Strategy. And the gist of this technology is it's a system that can orchestrate provisioning of ephemeral test sandboxes. If you can see there in like the orange and green. These containers are isolated from prod, and we built routing intelligence in our forwarding plane at the L4 layer to dynamically redirect test traffic to these test sandboxes. And the key part of this is the downstreams of your test sandboxes is the rest of production.
Also the upstreams too.
Also the upstreams. So you're getting the full fidelity of production. So maybe the first question that jumps to your mind is, hey, this is insane. Like, if you're testing against production, how can you guarantee you're not affecting other production users, right? So one of the key tenets of our design is, we all use Uber through our mobile apps, and there's public APIs that you use to access Uber's backends. When you actually access these APIs, it's all done through what we call like an account, and all the calls are authenticated and the side effects are scoped to that account. So we shipped the concept of a test account where all the side effects are isolated to that particular like tenancy of Uber. But Uber is actually a multiplayer marketplace architecture. So, not everything is just isolated to your own account, right? So you can think of it as like whenever you request a ride, you have to match with all the drivers out there. When you shop on Uber Eats, you might see restaurants, and these are all different types of account entities within our identity domain. And so in the cases where you have cross-entity interactions, we needed to go and add multi-tenancy support. And so these are just like two common strategies that we use at Uber. The left one is you might redirect your test tenancy data to a separate data store. The right one is you might save it to the same database, but you add a column and then you have some like filtering to segregate the data. All right. So a big part of the innovation that we did is really changing various aspects of Uber's infrastructure to accommodate this type of testing, right? This is not a common thing that you see in the industry, but we really had to build bits into every layer of infrastructure. Every platform piece had to understand, hey, we were launching these test sandboxes and they're not production, right? And so a key piece of this is the routing layer. And, we provision these test sandboxes, and on every test request, we inject what we call routing override baggage. This is injected using the OpenTelemetry baggage protocol. And it's basically just a spec for propagating this information across all the microservices and systems across Uber stack. The key technology that enables this is something we call context propagation at Uber. The high level gist of this is it just enables transmission of certain metadata across your systems, whether it's microservices, it could be Kafka queues, it could be distributed workflows, it could be cron jobs. All of them are integrated with context propagation at Uber. And then we actually had to go out and work with a bunch of platform teams to design and enhance their systems to support testing as well. So in addition to testing code changes, one of the most common types of changes people make at Uber is config. The config system at Uber is called Flipper. And the way that this works is anytime you make a configuration change, we'll provision a test sandbox that's preceded with those new configuration values. We dynamically reroute test traffic to it and ensure that the tests continue to pass on the proposed changes. So building all these things really let us shift left reliably at scale. So back to the original picture that Daniel mentioned, we used to be really good at detecting incidents at the right, but there were still incidents impacting users. With technology like Bits, we were actually able to shift it all the way to the left, where actually all of these integration and end-to-end tests are running before code is landed. Everything's done in parallel, and there could be at any time like 1,000 of these test sandboxes all running in production. Today, we actually have like over 4,000 of these end-to-end tests. Some of them are as sophisticated as like going through all API interactions for like the entire Uber Eats flow, shopping, logging in, selecting a restaurant, adding stuff to your cart, checking out, tipping, getting your food delivered, getting a receipt generated, and all these are run on your diffs, and usually in like sub 2-minute time per test. And it's fast and reliable enough today to run on over 50% of all diffs at Uber. So you might be looking at me and saying, hey, Quess, you're painting a pretty rosy picture of end-to-end testing. Like, was it really all that easy? And I think the answer is no, right? I think end-to-end testing has a lot more developer friction than more isolated forms of testing like unit and component tests. And so we actually had to come up with some unique strategies to make this better. The first innovation that we built is we actually looked at the distribution of our tests across Uber. And what's interesting is like here on the right, I think the point I want to get across is this distribution it's actually fairly bimodal. Most of our tests are very reliable, like they pass deterministically when run against production. Some subset of them are in a state of broken. Maybe someone changed some configuration, rolled out some environment change happened, right? But in the middle, you see a very small slice of tests that are actually what we call flaky. And what I mean by flaky is sometimes they pass, sometimes they fail. What we found in like the 5 years of doing this is with as few as like 2 or 3 retries, most of your non-determinism goes away. So anything like network latency, blips, with a few retries, that stuff goes away. So as long as that's handled, really the key strategy we have here is when tests move into this broken state, can we automatically quarantine them and to prevent them from blocking the rest of the engineering org? So we actually built a system at Uber that does this. It's called Testopedia. And it automatically will like file Jira tickets and assign flaky test bugs to owning teams. Another one of the common complaints that I got working on this is, hey, Quess, my diff is failing, but I don't know if it's because of my change or the test itself is broken, but I don't own this test, so what do I do? So we came up with something interesting called a placebo execution. And you can think of this as on every test execution we do, we actually trigger a parallel run against the test sandbox deployed with the main branch code. So this actually allows us to move beyond a binary signal for our tests. That's before it's like you just have pass or fail. Now you have a truth table where, for example, let's say your placebo execution against main passes and your diff execution fails. We basically guarantee that your diff introduced a breaking change and you got to go back and debug and fix it. But if the placebo run against main is broken and your diff execution is broken, then it's likely that either the test itself has an issue or production has an issue. Either way, don't land, but attention should be given to fix the test or fix production.
And I think I would add over here, this actually enabled us to actually measure if we were actually effective at catching actual incidents over here. Because when we actually got a failure from the primary run and a pass on the placebo, we were very confident that there was something with that change that caused the issue right there. And looking at the same change, if it was revised and we saw that the primary run passed and also the placebo passed, we were also very confident that something was changed in the code or the config in order to prevent an issue from moving to production. So for the first time, we were able to count this on a monthly basis and know it's like, this was actually making a big difference right here.
Right. But when developers actually had to debug and deal with a potentially broken test, we built a test management portal as well that provided all sorts of analytics and observability on top failing reasons, historical pass rate, maybe like latency hotspots, and even giving developers the tools to, temporarily downtime tests or opt them out of being disabled for flakiness detection. And so this type of usability improvements really helped developers own their own quality and gave them the tools to kind of own their own tests. The last kind of cool innovation that we built was an extension of distributed tracing. So after every test execution, we're actually able to build 2 indexes. Given a test, we're able to tell exactly what services and endpoints were covered by it. And we surface this information to users and developers so that they know, hey, what APIs in my system aren't actually being properly tested. So we built a lot of stuff. So what? Some of the key outcomes out of this initiative is Uber became significantly more reliable. We started tracking incident reduction controlled by developer productivity. So the metric we use is incidents per 1,000 diffs. And we saw like a 71% year-over-year reduction in this. There was even a recent email that went out where after the Uber Eats org adopted this type of testing, they literally saw their highest severity incidents go down to 0. And end-to-end tests were the main part of their strategy for that. On the second note, we were actually both surprised to this because we actually thought productivity might get hurt when people are spending time dealing with end-to-end tests, but the actual absolute count of diff velocity went up.
Yeah, we were hyper focused just on quality. It wasn't until we had to present this to Dara that we started digging into the data, and we saw that no, productivity actually went up, and it actually started to make sense. I mean, engineers aren't just coding. We're also mitigating incidents. We're also just trying to keep the company up and running. And when you reduce all that and you don't stop the entire company when something goes wrong because you've reduced that amount, engineers can actually focus on coding. Right. And it's actually more efficient to block a few individuals than an entire company. So even if you get it wrong, it's still much cheaper and efficient just to block a few folks.
The last one is the one I'm personally most excited about because one thing I've just been organically seeing is adoption of end-to-end tests actually is empowering engineering teams to build really deep domain knowledge of their systems and their surrounding systems. And you really see the engineering culture change in real time.
And we'll talk a little bit about the culture. So testing is not just an engineering problem. It's also a people problem. You have to really change the mindset. And that's hard to get a testing culture going. But the team really understood this right here, that if somehow we could get this flywheel going where we had very stable tests, and if everyone bought in and said, we're going to block, we're just not going to land these changes that would regress this test, then we would prevent this test from regressing, and therefore we would just constantly keep these test cases as stable as possible. But we had to get to that land blocking. So there was a little bit of a chicken and the egg type of situation. We had to get the test case stable to begin with. And so this is where things kind of changed. We had to take a pretty extreme ownership right here. And so something I got to learn from black box monitoring over here was that my mentor told me, black box is nothing unless it has a stable signal. So if that test case is not stable, we basically have not brought any value to Uber. And that really stuck because when I took over Bits and we had this project going, I knew from the start that if we couldn't get this test case stable, we couldn't convince folks that it was possible to own this and have this thing be sustainable, we had no shot of actually making this into an enterprise initiative and bring the value that we actually brought to the company. And so I actually want to thank the team a lot for that, because the team really stepped up. There was a lot of individuals as well from various teams who took testing very seriously and also reliability very seriously. And they were on call to make sure that every time that test case failed, someone was there to triage. Also just trusting that signal. So just undoing all that everyone loves. I hate the word flaky test, to be honest. Everyone likes throwing that thing around, but we had to really undo that a lot. And so a lot of innovation, the tooling that we built for managing your test cases and actually understanding in more detail about how did your test case fail was to get to the point where folks really trusted their signal. And even though a lot of folks actually asked us to say, we need these test cases to be 99.9% stable, at the end of the day, they actually didn't need that. The requirements that came back after was like, we can retry, and retrying is not that hard. And then second, even though there are individuals who will suffer a little bit more, the entire company isn't suffering. So it was a net gain, even though that the test cases aren't always going to be at 99 point something percent on the first run. It's also quite hard to do that because code change and config change aren't the only things that could regress the test case. We have incidents caused by just having hardware failure or data center issues or networking issues. So it's really hard to get that pass rate that high when you're running it at the volume that we're running. And at some point, the company just treated these test cases with high urgency. You got paged, and everyone jumped on it to make sure that this was actually looked at and that we could resolve these issues so that we can get back to writing code and deploying it. And even though we allow folks to opt out and say, you know what, if it's just too flaky, just turn it off. You can disable it. 25% of our test cases are enabled no matter what. And that just kind of shows a little bit of a change in the culture that I will take that flakiness and I will take it out of my vocabulary, because when this test case fails, it's actually providing me a very strong signal. So it's amazing to see how the test culture has changed over the years, because back in 2015, the person who owned that test case was me. I was the junior engineer owning that test case, for about 4 years, and other folks owned it too. But we took it to the extreme. I was on call every time that thing went off, to today where our most senior engineers are the ones who are in charge of maintaining this right here. But just as a little bit of a career advice, if you are a junior engineer and you really, really want to learn about your architecture, do some end-to-end testing, because that will give you that insight about how your company works. It's pretty amazing, once you start digging into things.
Thanks, Dan. So we've built a lot of cool things, and the culture has changed. What's next at Uber in the testing space? We've done this at large scale, but where is the state of quality and productivity? It's interesting because Dan and I, for the past 5 years, we've really been hyper-focused on testing the product changes that developers make to Uber's like business systems. Everything that we've designed for Bits is primarily for testing product-based microservices. It's just the closest to the business. We lose the most money if those things go down. But beyond this, Uber's infrastructure layer is getting much more complex. So Bit's core design of relying on the networking at the L4 layer actually doesn't scale to test stuff that's lower in the overall stack. So any changes that we want to make at the host level, container level stuff, if we want to test out like the new ARM architecture, it's really hard to do this, right? So at Uber, we're currently experimenting with new ways to do this type of like broad scale platform validation. And then beyond infrastructure, I think there's just so many actual different sources of entropy into your system. We don't have CI/CD everywhere, and we need to go out and make sure that safe rollout of code and config is adopted everywhere. I mentioned earlier that as part of building bits, we're actually one of the first systems to depend on context propagation. And more, we're actually finding that this is being viewed as a like core foundational technology that, hey, any initiative that requires distributed observability, latency profiling, attribution, all of these are dependent on context propagation. So we need to continue driving the reliability of this. And then even as we have been big proponents of testing against production, in some cases, you can still cause incidents. You can cause cache invalidation. You can cause noisy neighbor problems, hot sharding. And so in certain more sensitive systems, we're currently experimenting with better isolation by building out a version of a pre-production environment for people to test against. But we still sort of expect testing against production to be something that's widely used for the foreseeable future. So that about concludes our presentation on testing. If you're interested in more of what we have built, we actually recently published a blog post on the Uber site. And then Dan and I will actually also be manning the Uber booth. So if you are curious, definitely come talk to us. We're happy to share more of our learnings, but I'm also curious to hear how various other folks are thinking about this space. Yeah.
Yeah. And I just want to just take a moment to thank the infrastructure testing team at Uber, because they spent a lot of time building this out. It was over multiple years to get this thing out here. And while it's just Quess and I up here presenting, it was a real team effort. All right. Thank you.